Alrighty, everybody, I just got it okay to start our final planetarium show of the day. So for now, I'm going to be putting away our space trivia questions because now we're going to be heading into the unknown. Ooh. And good afternoon, everyone. Welcome to the Morrison Planetarium. Really quickly, I just want to introduce myself. My name is Christian. I want to be your planetarium presenter. And just a heads up, I'm not just a voice coming out of the walls. I'm actually a person, and I'm standing right behind you. Hey, how's it going, everybody? Don't hurt your necks. Look forward into the dome before you. That's where the whole show's going to be. I just want to let you know that I'm here. I'm an actual person. And everything that you see in purple right now is going to be one enormous screen, thanks to the help of 6 different projectors hidden throughout our planetarium dome. If you're looking for those projectors, they're hidden just below that purple glow. And folks, the show that we're going to be doing right now is different from all the other shows that we've done here at the Morrison today. This one's a little bit special, close and dear to my heart. This one's called Tour of the Universe. And with Tour of the Universe, this show is completely live. So you're going to hear my voice for the next 30 minutes. And what this show entails, well, we're going to be starting off pretty close to the Earth, and we're going to be zooming all the way out to the very edge of the observable universe. So hopefully by the end of the show, you won't have an existential crisis of where we are in space. But I do need to forewarn you, we are pretty small in the grand scheme of things, so just a heads up. And before we get started with our show, folks, I do have to go over some quick house rules just so that we're all on the same page and have an enjoyable time. First off, there's no food or drinks allowed inside. If you manage to bring any snacks or beverages, make sure those are put away till the end of the show. We want to keep the theater as clean as possible. It's pretty hard to clean in between the seats in a planetarium. And also, if you happen to have any cell phones, smartwatches, anything that produces really bright white light or loud sound, now's the time to turn them off, deactivate them, put them away for the next 30 minutes, as these can be very distracting and takes away from the planetarium show. And also, folks, if you need to head out early during our show, you're more than welcome to do so. All we ask is that you exit towards the top of the planetarium. That's where you're going to find the exits before, during, and after the show. So when in doubt, always make your way up the stairs. Although if you have trouble climbing the stairs, we understand the stairs are quite steep. So once the show finishes up, just remain seated for a little bit longer. We'll have a staff member escort you to a lower exit. And last but not least, folks, this show is quite immersive thanks to our 75-foot dome above us. If at any point during the show you start to feel overwhelmed, start to experience motion sensitivity, there's a really quick and easy trick to ground yourself. All you got to do is close your eyes, take a few big deep breaths, then your brain will remember that you're sitting in a planetarium in San Francisco and not hurtling across the universe, at least not more than the usual. Hee hee hee. But with that being said, it looks like we're ready to go. So I invite you all to sit back, relax, and let's begin our tour of the universe. Alrighty, everybody. As I mentioned, we're going to be starting off pretty close to the Earth, but not quite. We can see the city lights just down below, but right in front of us is this amazing human feat called the International Space Station, or the ISS for short. And a lot of people tend to ask me, hey, Christian, what is the International Space Station? I hear about it all the time in news and articles, but I don't really know what it is. Could you explain it for me? Well, of course, folks, the International Space Station is a research facility, a laboratory that orbits around our planet Earth. And they conduct so many different types of experiments up here that they're not normally able to do, like experiments closest to the ground, which has a lot of gravity. Some of the experiments that they'll conduct up here are things like, what happens when you try to grow plants in space? Do the plants grow the same? Do they grow differently with less gravity? Which way do the roots grow? Another one is, what happens when you try to spark a match in space? Does the flame act the same? Does that act differently? And one of my favorites is where they had 2 identical twins. One twin lived on Earth for about a year. The other one lived on the International Space Station for a year. After that year, they compared and contrasted the two. Turns out when you live in space for a long period of time, you tend to age a little bit slower. But not only that, you also lose a lot of muscle because you don't have gravity constantly working down on your muscles all the time, or a lot less of it. So if you plan to live in space for a long period of time, remember to exercise daily. And folks, the International Space Station looks really big here on our planetarium dome, but it's not that big in actuality. It's only about the size of American football fields. If you've never been to an American football game, don't worry, you can also use the entire California Academy of Sciences. That's about how big it is. And what's even more impressive is that this thing is going really fast. The International Space Station is going a whopping 17,000 miles per hour. where it orbits once around the Earth every 90 minutes, and it experiences 16 sunrises and 16 sunsets a day. Whew, how romantic. And this also looks really far away from our planet, but in actuality, it's not too far away. The ISS is only about 225 miles above the surface of our world. 225 miles? That's like going from San Francisco to Santa Barbara, a nice little road trip to get away with the family for the weekend, so not too bad. And to be honest, folks, this is as far as we put humans into space nowadays, because traveling to space is very expensive. You got to build yourself a rocket ship, buy yourself one, and then once you get your hands on that rocket ship, you have to get your hands on so much rocket fuel. You're going to need so much rocket fuel that you got to be able to escape the Earth's gravity. Once you get your hands on that fuel, you got to also account for all the food, water, and all the air you're going to be breathing while you're up here in space. And what's also really cool is that we are actually launching some new astronauts to the International Space Station. They just left and they should be arriving tomorrow. So we got some new additions to our astronauts on the International Space Station. One of them is a veteran and 3 of them are rookies, and one of them is Anna Kikina, the first Russian cosmonaut to be joining with a US launch. So very first one, very cool. And just to let you know, you can fit about anywhere from like 8 to 10 astronauts in here. It looks really big, but there's not a whole lot of leg space here at the International Space Station. But for now, folks, the International Space Station is just the first stop in our tour of the universe, so now we're going to see it slowly disappear compared to the city lights down below. And before we lose sight of the International Space Station, I want to add some nice little orbital paths so we can see it as it slowly disappears. Alrighty, folks, we've zoomed so far away now we're able to see the entirety of our planet Earth. And I want to let you know that the space program that I'm using here right now is something that you can go home and download, and you can fly through space just like how I am. The space program that I'm using here is something called OpenSpace. So if you go to your favorite search engine, type in OpenSpace project, you'll come across the link where you can download it. But just a heads up, OpenSpace is in its beta phase, which means that it's not completely finished. If we come across any bugs or glitches, I'll point them out. Hopefully we can look past them. Also, OpenSpace uses a whole lot of processing power. So if you have an older computer, I wouldn't recommend downloading it. You need a lot of storage and be able to process a lot of information. But if you got a newer computer or a gaming computer, give it a try. It's a whole lot of fun. But if you're a person like me that doesn't want to download anything, or you just don't have enough storage space, because I never delete anything, well, we also have another great alternative called NASA's Eyes. Just like the human eyeball, just go to your favorite search engine, type in NASA's Eyes, and then you can find some links. You don't have to download anything. You can fly through space, and it's so much fun. So OpenSpace Project and NASA's Eyes. But now that we got a sense of what we're using in here, let's make our way over to our nearest natural neighbor to us in space, the moon. And just to let you know, folks, we humans have been to the moon before, but that was a little while ago. That was between 1969 and 1972, thanks to NASA's 6 Apollo space missions that brought a total of 12 incredibly lucky guys to walk on the surface of the moon. They got to conduct science as well, and they got to have some fun. They got to play some golf up here as well. But again, last time we sent humans to the moon was 1972, a little more than 50 years ago or so. But don't worry, folks, we humans are making a return trip back to the moon thanks to NASA's new space mission called Artemis. Pretty much with Artemis, NASA wants to send humans to Mars, but before we send humans deep into our solar system, we got to figure out exactly how we're going to be living out here in space. So the moon is the perfect stepping stone to figuring out the logistics of how we're going to be doing that. And what's even more impressive is that NASA is going to be sending the first woman to the moon, but not only that, they're also going to be sending the first person of color to the moon, but not only that, they're also going to be setting up lunar bases throughout the moon. Pretty much, our technology has greatly improved in the last 50 years, and we're able to conduct a lot more science in a much more smaller Way. And one place where we want to set up a lunar base is the south pole of the moon. The reason why is because we found a lot of ice there, and ice is going to be very helpful for setting up a lunar bases because you can melt that ice, pass electricity through it, and you can separate the hydrogen and the oxygen. Both of those are very valuable. But again, we humans should be heading back to the moon in the next few years, so look out for any news about Artemis in the news. And folks, when we look at the moon here from Earth, sometimes the moon feels really, really close to us. Feels like you can reach out your arms and touch it. But the moon is really far away. It's about 240,000 miles away from the Earth. Whew, 240,000 miles. Some of the adults in this room may have a car with that many miles on it. And if you take better care of your car than I do, you can even imagine driving to the moon if you drove for about 4 months nonstop, going about 80 miles per hour. Although I wouldn't recommend it, the roads out here are poorly maintained. Hee hee hee. And from here on out, folks, we're going to need to use a more useful measuring stick because at this scale, using miles is kind of like using inches to describe the distances between cities because space is so big. So astronomers use a more convenient measurement known as light speed. And light travels at a mind-boggling speed of 187,000 miles per second. That's roughly about 300,000 kilometers per second. So while it took the astronauts more than 3 days to reach the moon, traveling faster and farther than any human has done so ever since, it only takes light 1.5 seconds to cross that distance at the speed of light. That's kind of like a short pause in conversation. But at last, folks, it's time for us to leave the moon behind, so everybody say bye-bye, moon. See you later. So cute. And now, folks, we're going to see the moon and the Earth in their orbits as they start to slowly fade away. In fact, before we lose sight of the moon, I want to add some nice planet trails, because again, space is so big, you can easily lose stuff out here. And folks, on our journey today, we're going to be traveling much faster than the speed of light. We're going to be traveling at the speed of the human imagination, thanks to the help of computer models like OpenSpace, showing us the most accurate images and information available to us. And now the nearest star to us, the sun, should be coming into view. So here comes the sun, do-do-do-do-do. And just to let you know, folks, the sun is also incredibly far away from us as well. The sun's about 93 million miles away from the Earth. Whew, 93 million miles away, that is a great distance. And remember, we're the third rock from the sun. 1, 2, 3, 93 million miles between us. In terms of speed of light, that's not too far away. In order for sunlight to travel that distance, it only takes sunlight about 8.5 minutes at the speed of light. That's really fast. But now that we have a nice bird's eye view of our solar system, let's do a quick refresher of what's here, because we got some good stuff in our solar system. Right in the middle, of course, we have our star, the sun. The closest planet to the sun, we have Mercury. Then we have Venus right over here. Then we got us, Earth, that's us. And then past Earth, we have Mars, the red planet. These are all the rocky terrestrial planets that we're able to land a spacecraft on. And then past the orbit of Mars, we have something called the main asteroid belts. And this is what it would look like if to highlight all the asteroids in our asteroid belt. There is a lot of them. And I don't know if you all have heard, but there was a space program mission called DART. Pretty much they were testing our asteroid defense system. And that happened about last week or so. And what they did was that they crashed a satellite probe into one of an asteroid's moons a little bit further away from us. It was not going to head towards us at all, but we wanted to test this defense system in case an asteroid was making our way over here. And it's been a week since then, and they noticed that there was a great change in that trajectory. And so it looks like that mission was quite successful. So too bad the dinosaurs probably would have been benefited from that space mission. But we're going to continue on because past the main asteroid belt, we have our bigger planets. We have our gas giants, the Jovians. We've got Jupiter, the largest of them all. Then we have Saturn, famous for its rings. And then now we have our icy gas giants. We got Uranus, the funny one, and Neptune. Whew, I almost said the wrong name. And of course, we can add everyone's favorite and lovable dwarf planet, Pluto. So here comes the orbit of Pluto, right over here on the top right of the screen. And a lot of people don't realize that Pluto hangs out here in this outer part of our solar system called the Kuiper Belt. And you're probably wondering, what's the Kuiper Belt? I've never heard of that before. Well, folks, the Kuiper Belt is going to be all this stuff. So past the orbit of Neptune, we have the Kuiper Belt, and we found more than 400 objects out here as of 2006. And that's the really cool thing about science, because as our technology gets better, our telescopes, our space telescopes, we're able to see much smaller objects much further away. So we came across all this stuff. And who knows, in the next 5-10 years, as our telescopes get better, maybe we'll find more things in the outer parts of our own solar system, just in our own backyard. But I want to put away the Kuiper Belt because that's just a whole lot to look at. Oh, I almost forgot. The Kuiper Belt's the second asteroid belt, mostly made up of icy asteroids. But putting that away for now because that's a lot. And right now I'm going to be adding on screen some many different spacecrafts we sent out to explore our solar system in the 1970s. Now on screen we have the trajectories of Pioneer 10, Pioneer 11, Voyager 1, and Voyager 2. And the latest of them all, New Horizons, which did a quick flyby of Pluto in 2015. We can see that interaction as we fly around. And just to let you know, all these spacecrafts are all traveling fast enough to escape the sun's gravity and leave our solar system behind. But even the most distant of these robot adventurers, Voyager 1, has not traveled as far as light travels in a single day. In order for sunlight to travel all the way out to the orbit of Pluto, it takes sunlight about 5 hours at the speed of light. 5 hours. Not too bad either. But for now, folks, we're going to be leaving our solar system and the planetary scale behind because now we're going to be heading into interstellar space, the space between the stars. Distance now becomes so immense, it's going to take us about 4 years at the speed of light just to reach the next star system to us, the Alpha Centauri system. Alrighty, I see Alpha Centauri just right above us. So again, right in the middle, that's our solar system, that's us. And as we get closer, you're gonna see Alpha Centauri is just on top. You can see it moving close by. And again, 4 years at the speed of light just to reach the next star system to us. But that doesn't really put into perspective of how long it would take us humans to travel that distance. Well, folks, if you're getting a rocket ship today, made your way over to Alpha Centauri, it's going to take you about 8,500 years to cross that distance. And that's just a one-way trip to the nearest star system to us. Whew. But folks, let's stop and consider whether humanity has made its presence known beyond our solar system, because now we're going to be stepping inside something called the radiosphere. So again, we're now inside the radiosphere, and this represents the current limits of the most distant radio signals humanity has ever broadcasted or rather leaked into space. And it extends about 90 light years in all directions, emitting out from the Earth. This first began in the early 1930s with strong radio waves, early television, radar signal, and then later the detonation of atomic weapons. All this stuff is emitting electromagnetic radiation strong enough to escape the Earth's ionosphere. And humans were broadcasting well before that, but the earliest radio was not quite powerful enough to escape the Earth. And since all these signals are electromagnetic, they are traveling at the speed of light, so this is kind of like humanity's electromagnetic footprint in the universe. And of course, the radiosphere is always expanding at the rate of 1 light year per year, so is anybody out there listening? And right now, folks, I'm going to be adding some many markers onto the screen. These many markers indicates on the many thousands of stars astronomers have discovered over the last 30 years, which has at least one or more planets orbiting around them. We call these planets exoplanets, and we're looking for any of them that are Earth-like with conditions suitable for life as we know it. So far today, we found 5,000 confirmed exoplanets in the nearby vicinity to us, 5,000 other worlds besides our own. And that 5,000 number is going to be increasing as the years continue, because we have space telescopes where their whole purpose is to find as many exoplanets as possible. In fact, if you look over on the left-hand side of the screen, you can see that we pointed our space telescopes in one direction of the night sky, and we found a whole heap of exoplanets. And as they continue to scan more and more of the night sky, they'll be finding exoplanets left and right. So that 5,000 number is going to be going up. Now, to say if any of them are Earth-like with conditions suitable for life as we know it, well, we cannot answer that question quite yet. pretty much new space telescopes are being developed and created right now. So it's going to be quite a while before those are launched into space. So we can't answer that question quite yet. But the more important point here is that quite a few of these planetary systems are within that 90 light year limit of our radiosphere and could have potentially received our signals. However, since radio waves travel at the speed of light, if there is anybody that's out there able to listen in and answer back, the communication delays between hellos could be decades in time. Now, to give you an example, let's say we live in a star system on the far left-hand side. Let's say this one right here. We find an alien civilization, let's say somewhere towards the middle. Let's say that one. We shoot them a text message. We say, hey, we live here. Takes 60 years to get to them. They listen in, answer back another 60 years. Folks, that is a 120-year conversation in the making. Whew, and I could barely wait for a text message from my friends. But of course, folks, planetary systems beyond the radiosphere, more than 90 light years away, have not heard from us yet, but eventually they will, as the radiosphere is always growing, but it becomes weaker as it does. And for now, I'm going to be putting away those exoplanet markers, and I want to leave our radiosphere up on screen, because as huge as humanity's electromagnetic footprint is, it is nothing compared to our Milky Way galaxy. Alrighty, everybody, we zoomed all the way out, and now we're able to see our entire galaxy, the galaxy that we live in, the Milky Way. And I've got to ask, can anybody see their house from here? Just kidding. And folks, our Milky Way galaxy is incredibly large. If you wanted to cross it from one side to the other, it's going to take you about 130,000 years to cross our galaxy one way. And not only that, our Milky Way galaxy is so huge, we estimate that there's at least 300 billion stars in our galaxy. If our recent discovery of so many exoplanets just within our small neighborhood, within this vast star city, is any indication, there could be billions of planets and potentially millions of Earth-like planets throughout our single galaxy. And before we leave our Milky Way galaxy, I want to show you what it looks like from a sideways perspective. When we look at it, you're going to notice that it looks like a big flat pancake, a little bit wobbly on the sides. And two important things about this. One, you probably went out in the night sky and you probably heard someone say, hey, look, you can see the Milky Way from here. What they're referring to is the Milky Way plane, this disk that we're seeing right here. That's what you see in the night sky. And two, this is very important because when astronomers and scientists want to learn about the universe, it's so much more easier for them to point their telescopes galactically north and galactically south, instead of looking through the plane of the Milky Way, which has planets, stars, gas, debris, things that block their view of the universe. So keep that in mind. We like to point our telescopes galactically north and south. But folks, the Milky Way galaxy is only one of many hundreds of billions of galaxies that comprise the known universe. So in this giant leap, every single point of light that you're now going to see no longer represents a star, but rather the location of an individual galaxy. Each galaxy containing hundreds of billions, perhaps trillions of stars. And we live in a local galaxy group which contains about 30 galaxies, large and small. Also includes the nearest large spiral to us, the Andromeda Galaxy, only 2 million light years away, just next door and heading right for us. We're going to get to know it pretty intimately in about 5 billion years, so mark your calendars. And folks, as we continue zooming out, you're now going to realize that galaxies are not evenly distributed throughout space. Instead, galaxies like to clump together in large groups and clusters, or they like to avoid each other where there's very few galaxies or no galaxies at all. So we can see a nice galaxy cluster right in front of us. We can see some galaxy clustering down below. We can see very few galaxies towards the top or no galaxies. You can kind of think of galaxies like people. They like to hang out together or they like to avoid each other. And folks, we've zoomed so far out now that this picture that we're looking at represents the closest 30,000 galaxies to us in a space over 300 million light years across. We got to give thanks to an amazing astronomer by the name of Dr. Brent Tolley, who worked at the University of Hawaii, who compiled this amazing representation thanks to the work of dozens of other astronomers working aside him over decades of time. So big shout out to Dr. Brent Tolley. But now, folks, we have automated systems that are mapping even the most distant galaxies. So folks, we're about to see the very large scale structure of the universe. And remember, folks, every single point of light that you're seeing, that's not a star, that's an individual galaxy. Whew, I feel small. And just to let you know, the large-scale structure of the universe is not in the shape of a bow tie or a butterfly. Remember when I mentioned that we live in a flat spiral disk of our Milky Way galaxy? Well, if it were to line up our Milky Way, it would line up just down the middle, like so. So again, we like to point our telescopes galactically north and galactically south instead of looking to the plane of the Milky Way. But astronomers still wanted to make sure that there was galaxies through the Milky Way plane, so we have this nice purple survey of galaxies right in the middle. You'll notice that they were still able to find galaxies, just not as many and not as far. Pretty much we have to wait for our technology to improve, and once that happens, we'll be able to map out all these areas that haven't been filled in yet, so it's just a matter of time. But folks, let's continue pressing on because we are running drastically low on our tour of the universe. 30 minutes is just not enough. And now we're going to be encountering these really distant, faraway objects known as the quasars, which are going to be these nice orange dots at the very edge of the large-scale structure of the universe. So we're going to see some quasars on the left. We're going to see some quasars on the right, coming in screen now. And folks, quasars are short for quasi-stellar radio sources. These blazing objects are all billions of light years away. So now we're looking so far back in the depth of time and space that the most distant quasars represent the universe at a much earlier age. We're nearing the very beginning of galaxy formation. In other words, with the quasars, we're viewing a sort of awkward, gawky teenage version of the universe, and before there was a teenager, there was a baby. So let's press back to a time before quasars, before planets, stars, and even galaxies began to form. Folks, we're about to see the very edge of the observable universe. Alrighty, everybody, here we are at the very edge of the observable universe, and what we're looking at is something called the Cosmic Microwave Background Image, or the CMB image for short. And all evidence indicates that the universe we live in is about 13.8 billion years old. And this is data compiled by Planck and other radio telescopes. And the picture that we're looking at is a baby version of the universe, only 380,000 years after the Big Bang occurred, where space and time began. And it's not a typical photo either. Instead, this is a temperature density image where the light echoes of the Big Bang are color-coded, where the lighter areas correspond to the hottest, least dense regions, and the darker areas the coolest, densest regions. These fluctuations in temperature and density are extremely tiny. They vary no more than 1 part per 100,000. But these really small differences eventually gave rise to the large-scale structure of the universe that we saw moments ago, that clumping and clustering of galaxies everywhere. Figuring out just how that happened is one of the larger challenges for cosmological research today. Though our view here is of the outer edge of the known universe, folks, the earliest light visible to us, that radiation actually persists all around us. It permeates the universe, stretching and cooling as the universe expands over billions of years of time. But folks, we've traveled as far back as the law of physics can physically allow us to go, so we only have one direction left to go, and that's going to be back towards planet Earth, home. So let's find a nice entry point through all these quasars and galaxies, and let's return home, folks. Alrighty, everybody, we're crossing an expanse of over 13 billion light years. We present you with this view of our universe and the latest in cosmological and astronomical information. We're covering eons and observing objects billions of light years apart. Now, we live in a golden age of astronomy with new generations of telescopes and spacecrafts that are extending the reaches of our eyes, preparing for the eventual race between the advancement of technology and the accelerating expansion of the universe. And with that thought, I want to remind you all that astronomy is for everyone. You don't need to be a rocket scientist to enjoy the beauties and wonders of our universe. All you need is the night sky, and if you can, get away from the lights of our cities and look up. Even a good pair of binoculars makes for a decent first telescope, and there's astronomy clubs all around the world that invite people just like you to look through their telescopes and peer into the great beyond, allowing you to partake in the wonders that our universe has to offer. Now, astronomy as a hobby can offer an endless supply of satisfaction, and I do hope you'll join us, those who dream amongst the stars. But hey, look at that, we made our way back into our Milky Way galaxy. We're heading right through that radiosphere. And of course, we are making our way downtown, walking fast, faces passing, we're homebound. Dun-dun-dun-dun-dun-dun. And we're now entering our solar system, folks. Passing the spacecrafts we sent out in the 1970s to explore that solar system, passing the orbit of Pluto and the Kuiper Belt, making our way to the third rock from the sun, our homeworld, planet Earth. All the people that you know, love, all lived on this one planet. And now we're about to pass the orbit of the moon, the furthest we've ever sent humans out into outer space. And folks, as we make our final approach back to planet Earth, this is going to be the end of our Tour of the Universe show. And I want to thank y'all for stopping by and watching it with me today. I hope you did enjoy it. But hey, look at that. We made it back home safe and sound. And that's it for now, folks. Thanks for stopping by, everybody.